Welcome to Spaceverse, your portal to cosmic adventures. The universe has always held its secrets close, silent, vast, and unknowable. But now, with new eyes in the sky, humanity has begun peeling back the layers of time. Across the great expanse of the cosmos, through veils of ancient dust and radiation, astronomers have glimpsed something extraordinary. A beacon from the beginning. A cosmic lighthouse shining from the edge of the known universe. Meet JWST 131LA, a galaxy so distant, so old, and so impossibly bright that it's rewriting what we thought we knew about the early universe. This isn't just a distant smudge in the sky. This is a relic from a time when the universe was only 330 million years old. To put that into perspective, Earth didn't yet exist. The Sun had not formed. Even our own Milky Way galaxy had not yet stirred to life. Yet somehow, this ancient light began a journey across time, traveling over 13.5 billion years through cosmic collisions, gravitational distortions, and vast stretches of interstellar space, until it reached us. And when it did, we were ready. Captured by the James Webb Space Telescope, this light is more than just a signal. It's a message from the dawn of time. When these photons left their galaxy, the universe was still cloaked in cosmic fog, a haze of neutral hydrogen that absorbed most of the visible light. Astronomers call this period the cosmic dark ages, a time before the stars had fully awakened, a time before galaxies sculpted the structure of space. And JWST 131LA was one of the first lights to break through. At that time, the galaxy burned hot, radiating intense ultraviolet light that could have illuminated its surroundings. But as the universe expanded, so did space itself. And with that expansion, the ultraviolet light stretched, shifting into the infrared part of the spectrum. Too long in wavelength for our eyes to detect. Too faint for ordinary telescopes. Until now. With its advanced infrared instruments, like the near-infrared camera and mid-infrared instrument, the James Webb Space Telescope is revealing galaxies that have remained hidden since the beginning. Galaxies like JWST 131LA. Astrophysicist Joris Wittstock and his team at the University of Copenhagen were among the first to examine this galaxy's light in detail. Their mission? To uncover clues about one of the most mysterious chapters in cosmic history, the Epic of Reionization. After the Big Bang, the universe was hot and dense. But as it expanded, it cooled. Protons and electrons combined to form neutral hydrogen, and suddenly the cosmos went dark. For hundreds of millions of years, the universe remained in this opaque state until the first stars ignited. With the birth of stars came the birth of light. These early stars and galaxies began emitting powerful radiation, enough to rip apart the surrounding hydrogen atoms, stripping electrons from nuclei and reionizing the cosmos. Slowly, bubble by bubble, the universe began to clear. This transformation from darkness to light is known as reionization, and JWST 131LA appears to sit right at the edge of that transition. By studying its light, specifically its redshift, its Lyman alpha emissions, and its color, scientists are uncovering the fingerprints of the universe's awakening. Because this galaxy doesn't just emit light. It glows with a power that defies expectations. Wittstock and his colleagues discovered that the galaxy is not only extremely luminous, but unusually blue. Its radiation peaks at the short, high-energy end of the spectrum, hinting at extreme astrophysical processes taking place within. And then there's the Lyman alpha signature. This ultraviolet emission line is produced when electrons in hydrogen atoms are excited by radiation, then fall back to their ground state, releasing photons in the process. It's a telltale sign of vigorous star formation. But in this case, the signature is far stronger than astronomers expected. Michel Trenty, another astronomer studying the discovery, explains it like this. These two facts combined, the blueness and the strong Lyman alpha, make this galaxy unique. They're inconsistent with what we see in more typical galaxies during the end of the reionization epoch. So, what could be powering such extraordinary light? There are two leading theories. First, a ravenous supermassive black hole. If this galaxy is home to one, it could be consuming surrounding matter at a furious rate, releasing vast amounts of energy in the process. But there's a catch. JWST 13-1LA existed less than 400 million years after the Big Bang. According to current models, there simply hasn't been enough time for a black hole to grow to supermassive scale, unless something is missing. Unless there was a previously unknown process in the early universe, one that allowed black holes to form faster or larger than anything we've seen before. There are certain theoretical models where this would be expected, says Wittstock. So if this is indeed the case, it could have very important implications for our understanding of early black hole formation. The second possibility? Stars. But not just any stars, massive, scorching, high-mass blue stars. Stars more than 100 times the mass of our Sun, burning 15 times hotter. These celestial giants would pour out ultraviolet radiation in volumes large enough to explain both the intense blue light and the powerful Lyman alpha signal. And if these stars are the source, they might also be among the primary drivers of cosmic reionization itself, which raises a profound question, one that lies at the heart of modern astrophysics. What powered the universe's great transition from darkness into light? Was it black holes? Was it these rare, massive stars? Or was it something else entirely? Trenny frames it perfectly. Where does reionization come from, and what kinds of radiation do they emit? Are common stars, rare stars, or accreting black holes the ones powering this process? Answering that question could reshape our understanding of how galaxies like the Milky Way formed, and how the universe evolved into the masterpiece we see today. Because JWST 13-1LM might be just one galaxy, but it's also a time capsule. A cosmic fossil containing evidence from a moment when the first stars burned, the first galaxies formed, and the universe emerged from its long, dark night. Yet for all we've learned, the cosmos still holds more questions than answers. Despite the breakthroughs made possible by the James Webb Space Telescope, astronomers like Wittstock and his team are still missing crucial pieces of the puzzle. As Trenny puts it, this discovery starts shining some light on when reionization started, but it is just a preview that stirs curiosity. It's hard to do science with a sample of only one object, but that's the thing about astronomy. Every answer leads to new questions. And so, the search continues. Wittstock remains hopeful. He believes that JWST 13-1LA is only the beginning, that galaxies like it are out there, just waiting to be seen. New JWST observations are already underway. Some have been captured. Others are scheduled for the months ahead. And each new data point brings us closer to understanding the early universe's composition, the precise mix of helium, carbon, and oxygen that powered these ancient lights. By comparing JWST's high-resolution spectra with computational models, scientists hope to determine not just how these galaxies formed, but why. And as of March 26th, this discovery is no longer speculation. It's been published in Nature, one of the most respected scientific journals in the world. It's a powerful reminder, even in a universe 13.8 billion years old. The future of discovery has only just begun. If you found this journey through time and space as awe-inspiring as we did, don't forget to like the video, subscribe, and tap the bell for more cosmic discoveries. Here on Spaceverse, we explore the mysteries of the universe, the latest space missions, and the science reshaping our view of the cosmos. Because out there, among the stars, the story of everything is still unfolding. Thanks for watching, and until next time, keep looking up.